Hi, everyone. It's me, Carolyn, and we are going to be talking about hypothesis testing in this video. Hypothesis testing is when statisticians do research and some of the steps that they have to go through the process. Now, again, we're just touching on things. We're just getting a taste of what actually happens. There is a lot more to the process that we will never even touch on. But I'll mention it as we kind of go some of the things that they also have to consider. So I'm going to start by sharing my screen so we can get to our guided notes. And this is chapter 10. And again, we're just going to touch on some of these hypotheses tests and how powerful or what we can be doing. So first of all, the definition. A hypothesis is a statement regarding a characteristics of one or more populations. And this is sometimes used also, this term is used in scientific methods as well, because a hypothesis is nothing more than a statement. And what we're going to be doing is we're going to be testing this. So we're going to be testing it. So it's a procedure which we're going to base on sample evidence. So we go out and gather some data based on a sample, and then we're going to test whether or not that hypothesis is false or not. So there are some steps that we go through. So first of all, it is a procedure based on sample evidence. So we'll be getting some sample evidence. Now, we are not actually going to be going out and gathering the evidence or gathering the sample. That is a very detailed part of this testing that we won't be seeing. The designing of the experiments or designing of how to gather the data, the designing of the surveys that are being sent out. So none of those sorts of things are things that we will be doing here. So the steps that we'll kind of be looking at is we're going to be making a statement. And again, those will be made for us because we're just going to be introduced to it. Is made regarding the nature of a population. Then what they'll do is they go out and gather some evidence to test this statement. And then what they'll do is they'll analyze that data, and then they will assess the plausibility of the statement that they made. Now, what we do here is we kind of write some more mathematically based statements. Yes, later on we will see that some of our hypotheses are more wordy than others, but we're going to start with more of a symbol type thing. And we do have two hypotheses. First of all, like the null hypothesis, which we denote H for hypothesis and the little zero, that's kind of like null, is the statement that we're going to be testing. So for example, let's just say we think that penguins eat on average 5,000 calories per day. This is sometimes usually an assumed truth. So something that is like the status quo, something that we think is true. The alternative hypothesis, which our textbook denotes with an H and then a 1. Other textbooks I've seen H with an A for alternative. It's just notation again. It's just the way we label them. And it's a statement that we're trying to find evidence for. So it's kind of like the alternative. So maybe someone thinks that penguins eat less than 5,000 calories a day. And so we'd be taking a sample and trying to determine if that is true or not. So the way that these things are going to look in this chapter anyway, is we will see, for example, our null hypothesis will be some parameter, and it'll be equal to some value. So for example, we might have that the mean, mu, is equal to 5,000. Notice that we do use the parameter, the symbol for that measurement of the entire population. We're not looking at X bar or our statistics, but we are talking about the entire populations in these tests. Now, our alternative can take on a couple of different ways. It could be a not equal to symbol. It could be a less than symbol. And it could be the greater than symbol. Now, it's going to be one of those three. It's not going to be more than one. So we are basically testing it equal to versus one of those three pieces. Our conclusions, once we do all the testing and we do some analysis on the sample data that we get, we are going to make a conclusion. And our conclusion is going to be either to reject the null, Okay, so we're not going to agree with that. So we would kind of be, yes, there's enough evidence to show these things happen, or we're not going to reject it. Okay, one thing we do not ever do is we never assume or accept that this is a for sure truth. Okay, it's kind of an assumed thing. So we aren't going to say, yeah, it's true. But we're just trying to, we can't, with that evidence, show that it's not true. All right, so for example, and this one I like to use a lot because it is the way our system in the Americans work, is the defendant is innocent, and we are assumed innocent until we can be proven guilty. Okay, so notice that here's our assumption, the defendant is innocent, and then versus the alternative, the defendant is guilty. Now, these are two things that happen every day in court. And if they're found guilty, then we reject this null and we state that the person is guilty. So we reject this. He's not innocent. He is indeed guilty. However, when we find that they were innocent, we don't say that they are innocent. We always state that the defendant is not guilty. In other words, there wasn't enough evidence to show any guilt, but we don't ever say that, yes, they're innocent. So just kind of things to keep in mind when we are writing our conclusions. A lot of times, to be more specific, when I write my conclusions, if it's rejected, I usually say there's enough or substantial or sufficient evidence to support whatever this alternative is saying. So I might say there was enough evidence to show that he was guilty. Or I might have said there's not enough evidence to show that he was guilty, so he is not guilty. All right, so let's do some more examples. Let's suppose researchers believe that penguins eat less than 5,000 calories as previously stated. So here would be our null. That would be the assumed, but they believe less than. So that's what our alternative would look like, would be a mu less than 5,000. If we rejected the null, so if we were to reject this, we would say that there's enough evidence to show that the penguins eat less than 5,000 calories. If we did not reject it, we would say something like there is not enough evidence to show that penguins eat less than 5,000 calories. I want to again note, and I can't really stress this enough, we don't ever say that they eat 5,000 calories. We just say that they don't eat less than 5,000. They might actually eat more, or we don't know. Based on the samples and evidence that we found, we can't say that they eat less at this time. All right, we can always make errors. So because samples are not always completely accurate, they're only a subset of our entire population, there are some errors that could be made. And these errors are sometimes labeled as a type 1 error and a type 2 error. And I'm going to go to our court idea because I think sometimes that is something a little bit easier to understand. So again, the court was the defendant is innocent. The alternative, he was guilty. A type 1 error would be sending this innocent person to jail. Okay, so we found enough evidence to prove that they were guilty, and we send them to jail. That would be a mistake because our person was not in fact guilty. So they're going to jail. The probability of that happening, so this probability of a type 1 error, we like to call alpha. And yes, this is the same alpha that we've been seeing all along in all of the notations that we've seen. So this alpha is carried along with us. Okay, a type 2 error is letting a guilty person go free. And what we do is we label that probability of that happening as beta. Now notice we can't have a perfect world where we don't make any errors. So we try to control one of these. And the one we like to control is this one because we feel that it is more how do I say this? That it is more crucial that we don't send innocent people to jail. So our system is set up that we have to make sure that this person, beyond a reasonable doubt, is proven guilty. So this type 1 error, we hope, is relatively small, which means in the same instance, if that is really, really small, this could be a lot larger than we would like it to be. So what happens as one goes up, the other one goes down. And again, we would rather assume the status quo remains consistent than to make changes before we're really certain that they are true. Okay, let's practice a little bit writing some hypothesis statements, because that is the first piece of stuff that we have to do. So here's an example. We have Paul believes that the average lifetime of a bug is 48 hours. His roommate says that that's not the case, and bugs live longer than that on average. So we need to write our null and our alternative hypothesis. I usually use the colon between the two. I think that's kind of the standard. The next thing is we have to decide what parameter or what parameter that we're measuring. And we're talking about the average lifetime. So average is our mean, is what we're talking about. So that's our parameter that we're looking at. And the status quo is that it's 48 hours. So equals 48. And remembering that our null is always the equals. The roommate says it's not the case. He thinks they live longer. So longer would be more than 48 hours. So those would be our hypotheses. Let's do a few more. All right, the standard deviation in the pressure required to open a valve is known to be 0.7 PSI, which is pounds per square inch. Due to changes in manufacturing, the quality control manager feels that this variability has reduced. So again, writing our hypotheses. We're looking at the standard deviation. Now we need the symbol for standard deviation of a population. That is our sigma. And it is known to be 0.7 versus the fact that the quality manager thinks that it has been reduced. So reduced would mean it's gotten smaller. Okay, we're going to do one more. And we have Sarah feels that 45% of all pizza orders are for pepperoni pizza. So again, H1, H it's not, and H1. Again, other textbooks do use an A instead of the 1. Again, it's just notation from one person to another. I don't think there's any magic to it. But we're looking at 45% of all pizza orders are for pepperoni pizza. The pizza police feel that that is not the correct proportion. All right, we are talking about the proportion. So that's our P. And we're thinking it's 45% or 0.45. Not the correct. Well, that would be not this. So not 0.45. Okay, some of the things that can help us determine what these hypotheses look like is to first of all remember that the first one is an equal statement. That null hypothesis will be an equal statement. The alternative is going to be one of the two inequalities or the not equal to. To help us determine which of those three, we've kind of made a list of some words that can help you with this. So here's our less than symbol. And some things that kind of tell me it's been less than would be like reduced, is less than, smaller, has depleted. They're faster, which means the time is less, shorter at most. So some of those terms might pop in here. And we've seen some of these terms before when we were dealing with probabilities and things as well. Our greater than symbol, increased is more than, bigger, larger, grown, slower, because that would mean more time, taller, and at least. The not equal symbol, well, not equal, has changed or is different from. So those are, I mean, these are just some of the terms that you might see to help indicate which of those three we will be using in the alternative hypothesis. So in this first section, we're just getting an introduction to, the hypothesis, the different types of errors. In the next sections, we are actually going to go through the steps of a hypothesis test and some of the details that go into it. But that is in our next video. So I am going to stop here and hope you have a great day, and I will see you in the next video.